Hi, for my robotics laboratory subject, this is my summative assessment for the midterm exam. So it is entitled Sensor Potentiometer with Serial Communications. So this is the PDF. I already downloaded it. And so as you can see here, the objectives of this experiment is to convert analog to signal digital for Arduino to process, to control the angular displacement of the robotic arm using the potentiometer, to create a computer program user interface to display data coming from Arduino. So, equipments and materials: a personal computer, one Arduino microcontroller, one servo motor, a potentiometer, one power supply, one breadboard, one set of connecting wires. Next, introduction. In this activity, we will control the joints of the robotic arm using a potentiometer as a sensor. We'll configure the potentiometer with a voltage divider circuit and feed the middle pin to the Arduino to have a variable value as we rotate the knob of the potentiometer. We will make use of the analog to digital conversion of the Arduino microcontroller in order to process the data. The data will be converted to angular displacement that will feed to the servo motor connected in the robotic arm. So MS Studio provides, for this part of the introduction, we're not going to use MS Visual Studio. Instead, we're going to use Arduino IDE for our display. So we're going to make a code that will display our program or the value of the servo angle and the potentiometer value using our 16:2 LCD. So this for the setup, we need to connect the computer and the Arduino microcontroller using the USB serial cable and connect the black cable to the ground, red cable to 5 volts, and yellow pin to pin 9 of the microcontrollers respectively. So this is the connection of the servo to the Arduino Uno and this to the potentiometer. So for the Arduino program, we need to create a program for the microcontroller that will control the angular displacement of the servo motor connected in the robotic arm by using a potentiometer. The angle created by the potentiometer will be imitated by the robotic arm. So for part 1, we're just asked to connect the circuit to our Arduino, and our display would only be using our serial monitor. So this is the actual circuit connection. Still, we're going to use the potentiometer for us to turn our angle value, and it's connected to our servo and of course the Arduino Uno. So that's the actual circuit connection. This is the circuit assembly using the FritzSync application. So here in our FritzSync, this is the connection of the circuit. So as you can observe, this is our potentiometer. This is the ground. It's connected to the ground of the Arduino. Our pulse for the potentiometer is connected to A0. Our VCC for the potentiometer is connected to the VCC, of course, of the servo, and the VCC of the Arduino microcontroller. And pin 9 of the Arduino is connected to the pulse of the servo, and of course the ground of the servo is connected alongside with the ground of the other equipments used. And the schematic diagram using FritzSync. So display using Arduino IDE serial monitor. So the angular displacement of servo motor controlled through potentiometer and displayed through Arduino IDE serial monitor. So this is the Arduino code. So this one. So for part 1, controlling a servo position using a potentiometer. Part 1, using viewing the values just using the serial monitor in the Arduino IDE application. So include servo library, my servo, create the servo object to control the servo. Integer potentiometer pin is 0, which is the analog pin used to connect the potentiometer. So integer value, so the variable to read the value from the analog pin, and the integer potentiometer for us to be able to read the value of our potentiometer. So void setup, serial begin, baud is 9800, my servo dot attach, pin 9, this attaches the servo on pin 9 to the servo object. So void loop, value equals analog read. So if our Arduino Uno reads the value of the potentiometer between 0 and 1023, then it will map the value and scale it with the servo between 0 and 180. Then when the when it's scaled, the servo will show the angle from which is it scaled to. So potentiometer then would read the value and scale it to the servo, just like what I said, and the servo will write and set the position according to the scaled value. So there in our serial print, in our serial monitor, this should be shown serial servo angle, the value that we got from our servo angle when we turn our potentiometer, and it will also print our potentiometer value from what we've turned also with our potentiometer. So there, the delay waits for the servo to get there to our desired, or to what we turned our potentiometer angle to. So to check this, if this works, so upload, compiling sketch, uploading, and unuploading. So I have my circuit here, so I'll just turn this. But first, of course, let's open our tools and servo monitor. So now it's at servo angle 4. So let's start at 0. So it's at 0. Let me turn it to 5. 5 is 34. 10 is 62. 15 is 86. 20 is 100. 15. 25 is 143. 30 is 174. 35 is 204. 40 is 233. 45 is 259. 50 is 289. 55 is 316. 60 is 343. 65 is 372. 70 is 402. 75 is 434. 80 is 458. 85 is 490. 90 is 518. 95 is 544. 100 is 575. 105 is 601. 110 is 623. 633 rather. 115 is 658. 120 is 689. 125 is 715. 130 is 744. 135 is 774. 140 is 803. 145 is 830. 150 is 859. 155 is 886. 160 is 966. 165 is 969. And 170 is 971. 175. 175 is 976. And 179 is 1023. There. So this is the table for our potentiometer value, the equivalent potentiometer value for the servo angle. So this was taken from the results of our serial monitor. So this is the actual circuit connection that I made. So this value is just not visible using my when I captured the photo, but this is visible on the naked eye. So here, my basis for me to let me just delete this. My basis for me to be able to connect this circuit is I first made a circuit assembly using FreeSync application. So here, let's zoom this. So as we can see, the servo is connected, just like what is asked from us in the instruction, is connected to pin 9 of the Arduino. This is for the signal. The VCC of the servo is connected to all of the VCC here, as you can see. Here, it's connected to the 5 volts there, and the ground of the servo, of course, connected to the ground of our Arduino. Next, let's check the connection of the LCD. So our LCD, the ground, of course, should also be connected here, all of the grounds, and the VCC also connected here, just like it's connected to the 5 volt and the VCC of the servo. And the SDA is connected to A4 there, and the SCL is connected to A5, and the signal for the servo here is connected to A0 in our Arduino Uno. And of course, the ground of the servo of the potentiometer, sorry, the potentiometer's signal is connected to A0 of Arduino, and the potentiometer's ground is connected to, of course, all of it are grounded, and the VCC of the potentiometer is also connected in here alongside with all the VCC of the other materials. So there, this is the schematic diagram, also via fritzing. And for the display using liquid crystal I2C, so for the LCD, you need to take note that we need to download from the www.arduino-libraries.info/libraries/liquid-crystal-I2-C. I downloaded this zip file here and used it in our Arduino IDE. So I included the what do you call this, the library, through clicking sketch, include library, and add zip library. So there, in my downloads, I just clicked on this library, liquid crystal, the one that I downloaded, and when you click again your include library, you'll find the contributed libraries, and then you'll click this for it to insert there. So I'll just delete this because I already have it here. Next, the Arduino code. So let's just go here. So for my Arduino, this is controlling a servo position using a potentiometer variable resistor. So there I included the liquid crystal _I2C, the library, for us to able to control or display our values using the LCD, and also the servo library for us to control our servo. So this is servo space my servo to create servo object to control a servo, and this LCD here is to display our values. Next, integer potentiometer pin equals 0. The analog pin is used to connect the potentiometer, and integer value, variable to read the value from the analog pin, and for the potentiometer, variable to read the potentiometer value from through our Arduino. Void setup, serial.begin 9800, that's for the board. My servo.attach, pin 9, so attaches the servo on pin 9 to the servo object. So lcd.init, so, and lcd.begin 16.2, so this is for the display of our LCD and the backlight for it to turn on. And for the void loop, this is the main code itself. So the value equals analog read, so reads the value of the potentiometer, what we're going to turn our what value that we're going to turn our potentiometer. It will read it, and the value will be mapped, and the potentiometer will read the value, scale it, and use it with the servo between 0 and 180. And once the potentiometer has scaled it, and then the my servo.write parenthesis value will set the servo position according to the scaled value. After this, then you can observe from the circuit that the servo motor will reflect the potentiometer value because it already scaled it between 0 to 180, which our servo can read. And in our LCD, with the code serial.println, the servo angle will be displayed with the value of this, the reflected value of our potentiometer again, because it was scaled to for the servo to be read and for the servo to read, and it will be displayed here what value our servo has. So it will be an angle value from 0 to 180. And next, the potentiometer value will also be displayed in our LCD, and the serial.println, the potentiometer value, which was from our as we turn our potentiometer. And lastly, this will print it in our this code LCD.print will print it in our LCD along with the value, and the set cursor is 01. This also will plot our potentiometer value and the value again for the potentiometer, and it will have a delay of 15 milliseconds. And there, LCD clear for it to clear on a loop. So as we turn our potentiometer, it will clear instantly with 0.15 milliseconds. So for us to check our code, of course, we need to upload. As we can see, compiling sketch, uploading, and done uploading. So I will now stop my screen record and I will show you the circuit connection, and I'm going to turn the potentiometer and show you the LCD. So now let's test my circuit. So this is my circuit connection. This is my potentiometer. It is connected to my LCD display and my Arduino Uno and my servo motor. So as you can observe, servo angle is 0, potentiometer value is 0, and it is because it is fully turned counterclockwise. And now, as you observe the servo motor and the LCD display, as I turn this, you can observe the servo angle increases and the potentiometer value as well. It's just not that visible in the recording, but it's visible in the naked eye. So as you can see, the servo motor rotates, and as I put it back or turn it counterclockwise, it goes back to a full 180 degree. There. Also, the potentiometer value changes. So now let's check our potentiometer value with our angle with an increment of 5. So let's start at 0. So 0, potentiometer value is 0. So 5 is 32 or 33. 32. Now let's try 10. 10 is 61, 62. 15. 15 is 91. 20 is 118. 25 is 146. 30 is 176. 35 is 201. 40 is 131. 45 is 259. 50 is 287. 55 is 315. 60 is 348. 65, 372. 70 is 401. 75, 430. 80 is 460. 90 is 516. 95 is 544. 100 is 575. 105, 602. 110, 631. 115, 662. 120, 690. 125, 716. 130 is 746. 135 is 775. 140 is 804. 145, 834. 150, 858. 155, 890. 160, 917. 165, 943. 170, 972. 179, 1023. There. So this is the compilation of the data that we've recorded earlier. So this is the table for part 2, servo angle potentiometer value table. This was taken from our LCD. From the results of the activity, it can be observed that there are just minimal difference between the results gathered from the Arduino IDE serial monitor and the 16:2 LCD display. One notable similarity is that both of them, of course, when servo angle is 0, potentiometer value is 0, and when servo angle is 179, potentiometer value is 1023.